Every time I move assets across blockchains, I remember a hard truth from my years in digital forensics: the point where two systems meet is almost always the weakest link. Bridges are the connective tissue of a multi-chain world, yet they have also been the epicenter of some of the largest exploits in crypto history. In this article, I want to share what I've learned building and auditing cross-chain infrastructure, and how you can transfer value between networks without becoming the next headline. Why bridges exist, and why they break. A blockchain bridge lets you use an asset native to one network, say, USDC on Ethereum, on another, like Stellar or Polygon. Since chains don't natively talk to each other, bridges typically lock an asset on the source chain and mint a wrapped representation on the destination chain, then reverse the process to redeem. The problem is that this model concentrates enormous value in smart contracts and validator sets. The numbers speak for themselves. According to Chainalysis, bridge exploits accounted for roughly $2 billion stolen in 2022 alone. The Ronin bridge hack, $625 million, and Wormhole, $325 million, weren't failures of blockchain cryptography, they were failures of key management, validation logic, and signature verification. In my forensic work, I've traced incidents where the on-chain code was flawless but a single compromised validator key opened the vault. The lesson keeps repeating to teams is simple: the security of a bridge is the security of its weakest custodian. Architectural models: choose your trust carefully. Not all bridges carry the same risk. I generally classify them into three categories: trusted, federated. Bridges rely on a set of known validators or a multisig. They're fast and cheap but reintroduce centralized custody. You're trusting humans and their keys. Trustless, like client/native verification, bridges verify state proofs directly on-chain. They're far more secure but computationally expensive and complex to build. Liquidity network bridges, like atomic swaps or hash time-lock contracts, avoid minting entirely, swapping assets through pooled liquidity. They minimize custodial risk but depend on available liquidity depth. On Stellar, I've found the ecosystem particularly well-suited to safer cross-chain design. With Soraban smart contracts and Stellar's built-in issuance model, you can implement tokenization flows where wrapped assets are transparently backed and auditable on-chain.